everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem: solve d square minus 4d plus 3 into y equals to 2 cos x plus 4 sin x. So firstly, let's find order and degree of the given differential equation. Identify the highest derivative. Here d square is the highest derivative, so our order will be 2. And the highest power of the highest derivative is our degree. Degree is 1, or just write the given differential equation as d square y minus 4 dy plus 3y equals to 2 cos x plus 4 sin x. Right? We know that d is a differential operator. Then d square will be d square by dx square. Now we can write the equation as d square y by dx square minus 4 into dy by dx plus 3y equals to 2 cos x plus 4 sin x. Right? Here the highest derivative is d square y by dx square. So our order will be 2, and the highest power of the highest derivative is a degree. Degree is 1. Right? Now coming to the problem. Given differential equation d square minus 4d plus 3 into y equals to 2 cos x plus 4 sin x, which is an operator form. F of d into y equals to q, where f of d equals to d square minus 4d plus 3 and q equals to 2 cos x plus 4 sin x. Here now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function. We'll find this using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. If you equate RHS to 0, then we'll get f of d into y equals to 0, which is a homogeneous equation to the given non-homogeneous equation. Right. Now, here yp is a particular integral, and we'll find this using 1 by f of d into q. So firstly, let's find complementary function using the auxiliary equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we are having f of d square minus 4d plus 3. So let's replace differential operator by m, then we'll get f of m equals to m square minus 4m plus 3. Then our auxiliary equation becomes m square minus 4m plus 3 equals to 0. Now let's split this minus 4m as minus 3m minus m. Then we'll get common factors. Okay, let's take m common from the first two terms. We'll get m times m minus 3. Now take minus common from the next two terms, or minus 1 common from the next two terms. Right? So here m minus 3 is common in two terms. So let's take m minus 3 common. We'll get m minus 3 into m minus 1 equals to 0. Now equate each factor to 0. From m minus 3 equals to 0, we'll get m equals to 3. From m minus 1 equals to 0, we'll get m equals to 1. Right? Then m equals to 3, 1, or m equals to 1 and 3. So now we got the roots which are real and distinct. Therefore, m equals to 1, 3 are the roots of our auxiliary equation which are real and distinct. Now let's write complementary function. If two roots say m1 m2 are real and distinct, then our complementary function will be one constant into e power 1 root into x plus the other constant into the other root into x. Now our complementary function looks like this: c1 e power 1 into x plus c2 e power 3 into x. Then y is equals to c1 e power 1 into x plus c2 e power 3x. Now let's find particular integral. We'll find particular integral using 1 by f of d into q. We have f of d, d square minus 4d plus 3 into q is 2 cos x plus 4 sin x, right? You can write this as 1 by f of d into first term 2 cos x plus 1 by f of d into second term 4 sin x. Here 2 is a constant and 4 is a constant, right? So let's take it outside. We'll get 2 into 1 by f of d into cos x plus 4 into 1 by f of d into sin x. Now we have yp, 2 into 1 by f of d into cos x plus 4 into 1 by f of d into sin x. Now you can find each term separately, or you can just go with the flow. Firstly, let's find each term separately. I'll just name this term under brackets as yp1 for my convenience, and this term as yp2. Firstly, we'll find yp1, 1 by f of d into cos x. Here we have 1 by f of d into cos x, which is of 1 by f of d into cos ax form, right? Compare cos x with cos ax and we'll get a equals to 1. Now we need to find d square, which is given by the formula minus a square. Then for a equals to 1, we'll get minus 1 square equals to minus 1, right? Now, see, d square appears in the denominator, right? So let's see what happens if we replace d square by minus 1 in the denominator. Always remember that denominator must be non-zero. If you get something like this, if the denominator becomes 0, otherwise then 1 by 0 becomes undefined. So the total term becomes undefined. Okay, I'll just take this denominator and check by replacing d square by minus 1. We'll get minus 1 minus 4d plus 3, which is equals to minus 1 plus 3 is 2 minus 4d, which is equals to take 2 common, you get 1 minus 2d, right? Which is non-zero. So we'll get non-zero by replacing d square by minus 1. So what we can do, we can just replace d square by minus 1. Then this becomes 1 by minus 1 minus 4d plus 3 into cos x equals to 1 by minus 1 plus 3 is 2 minus 4d into cos x. Now we can take 2 common from the two terms of denominator. Then we'll get 1 by 2 into 1 minus 2d into cos x. Again split this as 1 by 2 into 1 by 1 minus 2d into cos x. If you notice, you are having 1 minus 2d in the denominator, right? If you just change this minus to plus, you'll get 1 plus 2d. Now multiply and divide 1 plus 2d to this fraction, okay, into cos x. Now yp becomes 1 by 2 into 1 into 1 plus 2d is 1 plus 2d by 1 minus 2d into 1 plus 2d. 1 plus 2d into 1 minus 2d into cos x. So the denominator is of a plus b into a minus b form. We can write it as a square minus b square. Then this becomes 1 by 2 into 1 plus 2d by a square 1 square minus b square 2d whole square into cos x, right, which is equals to 1 by 2 into 1 plus 2d by 1 square is 1 minus 2d whole square is 2 square 4 into d square into cos x. If you notice, again d square appears in the denominator, right? So what we have to do, we have to see what happens if we replace d square by minus 1. Always remember that the denominator must be non-zero. Now I'll just take the denominator part and replace d square by minus 1. We'll get 1 minus into minus plus 4, which is equals to 5, non-zero, right? So denominator will be non-zero after replacing d square by minus 1. So what we can do, we can just replace d square by minus 1. Then yp1 becomes 1 by 2 into 1 plus 2d by 1 minus 4 into replace d square by minus 1 into cos x equals to 1 by 2 into 1 plus 2d by 1 minus into minus plus 4 into cos x, which is equals to 1 by 2 into 1 plus 2d by 1 plus 4, 5 into cos x. This becomes 1 by 2 into, we can split this as 1 by 5 into 1 plus 2d into cos x is equals to 1 by 2 into 1 by 5 is 1 by 2 5s are 10 into 1 into cos x is cos x plus 2d cos x. You know that d is a differential operator. Just replace d by dx. Right? Now we need to find derivative of cos x with respect to x is equals to 1 by 10 into cos x plus 2 into derivative of cos x is minus sin x. This becomes equals to 1 by 10 into cos x plus into minus 2 sin x. Or you can just write this as 1 by 10 into cos x minus 2, 1 by 10 into 2 is 2 by 10 into sin x. 2 1s are 2 5s are. This is equals to 1 by 10 cos x minus 1 by 5 sin x, right? Therefore yp1 equals to 1 by 10 cos x minus 1 by 5 sin x. Now let's find yp2. We have yp2 1 by f of d into sin x, right? This is of 1 by f of d into sin ax form. Compare sin x with sin ax, we'll get a equals to 1. Now we need to find d square, which is given by minus a square. For a equals to 1, we'll get minus 1 square, which is equals to minus 1, right? Now, take the denominator part and see what happens if we replace d square by minus 1. Always remember that the denominator must be non-zero, right? We'll get minus 1 minus 4d plus 3, which is equals to minus 1 plus 3 is 2, minus 2d, which is non-zero. So the denominator is non-zero by replacing d square by minus 1. So let's replace d square by minus 1 square, which is minus 1. We'll get 1 by minus 1 minus 4d plus 3 into sin x, which is equals to 1 by minus 1 plus 3 is 2 minus 4d into sin x, which is equals to 1 by. Now take 2 common from the two terms of denominator. We'll get 2 times 1 minus 2d into sin x. Again we can write this as 1 by 2 into 1 by 1 minus 2d into sin x. This becomes 1 by 2 into 1 by 1 minus 2d. See, here we are having fraction 1 by 1 minus 2d. If you can change this minus as plus, you'll get 1 plus 2d, right? Let's multiply and divide 1 plus 2d to this fraction, okay, into sin x. Is equals to 1 by 2 into 1 plus 2d is 1 plus 2d by 1 minus 2d into 1 plus 2d is 1 plus 2d into 1 minus 2d into sin x. So the denominator is of the form a plus b into a minus b. We can write it as a square minus b square, right? Then this becomes 1 plus 2d by a square minus b square into sin x, which is equals to 1 by 2 into 1 plus 2d by a square. 1 square is 1 minus 2 square d square. 2 square is 4 into d square into sin x. Again, d square appears in the denominator. So what we have to do, we have to check by replacing d square by minus 1 by right. Now this becomes 1 by 2 into 1 plus 2d by, okay, let's take the denominator part and see what happens if we replace d square by minus 1. We'll get 1 minus into minus plus 4 is equals to 5, non-zero. So the denominator becomes non-zero by replacing d square by minus 1, right? So here we need to replace d square by minus 1. Then this becomes 1 by 2 into 1 plus 2d by 1 minus 4 into minus 1 into sin x is equals to 1 by 2 into 1 plus 2d by 1 minus into minus plus 4 into sin x is equals to 1 by 2 into 1 plus 2d by 5 into sin x. Now we can write this as 1 by 2 into 1 by 5 into 1 plus 2d into sin x. This becomes 1 into 1, 1. 2 5s are 10 into 1 into sin x plus 2d sin x. We know that d is a differential operator, so let's replace it by d by dx into sin x. Here we need to find derivative of sin x with respect to x. We'll get 1 by 10 into sin x plus 2 into derivative of sin x with respect to x is cos x, right? Or 1 by 10 sin x plus 2 into 1 by 10 is 2 by 10 cos x. 2 ones are, 2 5s are. This becomes 1 by 10 sin x plus 1 by 5 cos x. These are yp2. So now let's replace yp1 and yp2 in yp. Yp becomes 2 into yp1 1 by 10 cos x minus 1 by 5 sin x plus 4 into yp2 1 by 10 sin x plus 1 by 5 cos x is equals to 2 into first term 2 by 10, 2 into 1 by 10 is 2 by 10 into cos x minus 2 into 1 by 5 is 2 by 5 sin x plus 4 into 1 by 10, 4 by 10 into sin x plus 4 into 1 by 5, 4 by 5 into cos x, right? 2 ones are 2 5s are, 2 2s are 2 5s is equals to 1 by 5 cos x minus 2 by 5 sin x plus 2 by 5 sin x plus 4 by 5 cos x. Now minus 2 by 5 sin x plus 2 by 5 sin x gets cancelled. We'll get 1 by 5 cos x plus 4 by 5 cos x. Now take cos x common from these two terms. We'll get 1 by 5 plus 4 by 5 into cos x is equals to, take the LCM of 5 and 5 is 5, right? In the numerator we'll get 1 plus 4 into cos x, which is 5 by 5 cos x. Yp becomes 1 plus 4 5 by 5 into cos x, which is cos x. Therefore yp equals to cos x. Now let's write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to, we have yc c1 e power x plus c2 e power 3x plus yp cos x. Right? This completes the problem. Now let's see how to solve yp directly. Is equals to 2 into, here you're having, actually this is 1 by f of t into cos ax form. Then for a equals to 1 we'll get d square equals to minus 1, right? So let's replace d square by minus 1. We'll get, obviously we have one d, right? One term involving d. So the total denominator becomes non-zero by replacing d square by minus 1. So we can just write d square directly. We can just replace d square directly here. Plus 4 into, here also this is 1 by f of t into sin ax form. Then for a equals to 1, we'll get d square equals to minus 1. By replacing d square by minus 1, we'll get one real number and one real number here. And in middle we have a differential operator, right? Term involving differential operator. So definitely the denominator will be non-zero by replacing d square by minus 1. So we'll replace d square directly in the denominator. equals to 2 into 1 by minus 1 plus 3 is 2 minus 4d into cos x plus 4 into 1 by minus 1 plus 3 is 2 minus 4d into sin x, which is equals to 2 into, just take 2 common from the denominator, or you can just go with this. I mean, you can just take 2 plus 4d, okay, and multiply 2 plus 4d to this fraction. Plus 4 into 1 by, take 2 common, you'll get 2 times 1 minus 2d into sine 2x, right? 2 2's gets cancelled, 2 1's are, 2 2's are, this is equals to 1 by 1 minus 2d into, now multiply and divide with 1 plus 2d into cos x plus 2 into 1 by 1 minus 2d into, multiply with 1 plus 2d, multiply and divide with 1 plus 2d into sine x. Then yp becomes 1 into 1 plus 2d is 1 plus 2d by, in the denominator you are having 1 minus 2d into 1 plus 2d, which is of 1 plus a plus b into a minus b form. We can write it as 1 square minus 2d whole square, okay, into cos x plus 2 into 1 into 1 plus 2d is 1 plus 2d by, again in the denominator we are having 1 minus 2d into 1 plus 2d, which is of a plus b into a minus b form. We can write it as a square minus b square into sine x. This becomes 1 plus 2d by 1 square is 1 minus 4, 2 2's are 4, I mean 2 square is 4 into d square cos x plus 2 into 1 plus 2d by 1 square 1 minus 2d whole square is 4d square into sine x. Again d square appears in the denominator, right? So here we have a equals to 1, then we'll get d square equals to minus 1. Here also we have a equals to 1, so d square will be minus 1, right? And see, by replacing d square we'll get minus 4 into minus 1, which is plus 4, and 1 plus 4 is 5, which is non-zero. By replacing d square we'll get non-zero term in the denominator, so we can just replace d square directly here. And here also we'll get the same thing, right? Because we are having 1 minus 4d square and we have d square equals to minus 1. Then we'll get 1 plus 2d by 1 minus 4 into minus 1 into cos x plus 2 into 1 plus 2d by 1 minus 4 into minus 1 into sine x is equals to 1 plus 2d by 1 minus into minus plus 4 into cos x plus 2 into 1 plus 2d by 1 plus 4 into sine x. Now this becomes 1 plus 2d by 1 plus 4, 5 into cos x plus 2 into 1 plus 2d by 5 into sine x. We can split this as 1 by 5 into 1 plus 2d into cos x plus 2 into 1 by 5 into 1 plus 2d into sine x. This becomes 1 by 5 into 1 into cos x is cos x plus 2d cos x plus 2 into 1 by 5 into 1 into sine x is sine x plus 2d sine x, which is equals to 1 by 5 into cos x plus, here d is a differential operator. So find the derivative of cos x here. We'll get 2 into minus sine x plus 2 by 5 into sine x plus 2 into, find the derivative of sine x, which is cos x, is equals to 1 by 5 into cos x is 1 by 5 cos x, plus into minus minus 2 into 1 by 5 is 2 by 5 sine x, plus 2 by 5 into sine x is 2 by 5 sine x, plus 2 2s are 4 by 5 cos x, right? Here minus 2 by 5 sine x plus 2 by 5 sine x gets cancelled and you'll get 1 by 5 cos x plus 4 by 5 cos x. Now take cos x common. We'll get 1 by 5 plus 4 by 5 into cos x, which is equals to 1 plus 4 by 5 into cos x, which is 5 by 5 cos x, right? 1 plus 4 is 5, so you'll get 5 by 5 cos x, which is equals to cos x. This is the yp. So this completes the problem. This is how we'll find yp directly here. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.